Whereas in case of a trajectory planning, we'll have two different types of motions, path to point motion, and we'll have a continuous path motion. Point to point motions பார்த்தோம் அப்படின்னா we'll have a each initial and final points. So intermediate path is not a critical one and it is computed by the controller. Applications வந்து பார்த்தோம்னா we'll have a moving of parts, spot welding, automated loading and unloading of machines, pick and place motion. Continuous path motions வந்து பார்த்தோம் அப்படின்னா used when there is a need to follow a complex path through 3D space, possibly at high speeds. So points generally turned by manually through which high speed automatic sampling over. So point to point motion. So simple point to point smooth trajectory with a few constraints on the lift off and set down positions. So we'll have a 3 days and manipulator which can move from point to point. We'll have a sleeve motion, we have a joint interpolated motion, we'll have a straight line motion. So sleeve motion பார்த்தோம் அப்படின்னா all joints move to the required knee position as quickly as possible. All axes begin motion at the same time but arrive at the destination at different times. So this generally results in joint gear and unpredictable arm motions, whereas in the case of joint interpolated motions, it requires the controller to calculate which joint will take the longest to arrive at a destination and slow other joints down accordingly. A separate velocity will be calculated for each axis and we'll have a manipulate motions is generally smooth and the wear will be reduced over time. Whereas the case of a straight line motion is a particular case of continuous path motions. So point to point motions joint based trajectory will be using over on it. அதே மாதிரி lift off and set down points will be provided for satisfying acceleration constraints. The cubic polynomial trajectories எடுத்தோம் அப்படின்னா we'll have a single joint degree of freedom. So theta of naught and theta of f இருக்கும். So both will be depending with on each other over on it. Okay. So similarly, we'll have a fourth constraints இருக்கும். அப்போ cubic polynomial எடுத்தோம் அப்படின்னா a0 plus a1t plus a2t square plus a3 t cube இருக்கும். So cubic polynomial trajectory எடுக்கும்போது we have to go for the boundary conditions, that is position at t is equal to 0, position at t is equal to final. Similarly, velocity at t is equal to 0, velocity at t is equal to final. அப்போ cubic polynomial எடுக்கும்போது when you are differentiating the expression, we can able to get the value of an a1 plus 2a2t plus 3a3 t square. So when we are clicking all these things, so we'll be solving the value of a3 and a2. We'll get the expression 3 by tf squared of theta minus theta and minus 2 of 3 by f theta. So thus we can able to find the value of an a2 and a3. So we have to find out the two conditions with the value of an initial and final velocity to be 0 and the value of acceleration. So final expression what we are getting over here, the value of a naught is equal to theta of naught and this a1 is equal to 0. So only the value of a2 is equal to 3 by 3 x squared of theta minus theta naught and a3 is equal to 2 by 3 x squared of theta minus theta naught. So acceleration பார்த்தோம் அப்படின்னா that is we have to do the 2 times repetition of this value, so we can able to get the value of theta naught. So theta and this over. And next time we'll be going for an quintic polynomial trajectory. So in the case of an quintic polynomial trajectory, so we'll have a cubic which allows us to define the position and the velocity. Okay, so at each location in that trajectory. So when we are saying about an acceleration about the quintic polynomial, so accelerations will be the discontinuous wave. So if you want to specify the acceleration அப்படின்னா we have to go for an 5 order polynomial. So for what we have seen about an cubic polynomial. So in order for the quintic polynomial, we have to consider 5 order polynomial by considering the initial and final positions and velocity and the acceleration or to be the boundary conditions for solving our coefficient. Okay. So let me consider the 5 order polynomial we have written with respect to the matrix over on it. Okay. So that we can able to solve the values and we have to find out the inverse for each join so that we can able to find out the solutions for that. So what are all the boundary conditions we'll be requiring? We'll be having of an initial position, initial velocity, initial acceleration. Similarly, we'll have a lift off position and what about the continuity in its position, velocity and acceleration. So either T1 and T2 ரெண்டுக்குமே வரும். So lift off வரும்போது we'll have a set down position. Similarly, initial consider பண்ண மாதிரி we'll be requiring about an final position, final velocity and final acceleration. Okay. So இப்போ known parameters அப்படின்னு எடுத்து பார்த்துக்கிட்டோம் அப்படின்னா initial and final values தெரியும், intermediate values தெரியும். ஓகேவா? ஸோ இதுல எல்லாமே what we know it of அப்படின்னு பார்த்தீங்கன்னா we know about an position, velocity and acceleration. So position given இருக்கும், usually velocity and acceleration will be zero. So positions கொடுத்திருப்பாங்க, velocities அப்படிங்கிறது பார்த்தோம்னா so we have to continue with the previous trajectory statement. So இப்போ solution எடுத்தோம் அப்படின்னா for example if I nth order polynomial எடுத்தோம்னு வச்சுக்கோங்களேன், it has to be satisfied n plus 1 conditions. இப்போ 13th order எடுத்தோம் அப்படின்னா so it has to go for an 14th. Okay. So then what you have to see here அப்படின்னா what are the procedures which you have to use for task based project planning. So procedure எடுத்துக்கிட்டோம் அப்படின்னா first thing we have to obtain the function. Okay, so from obtaining the function we have to go for an sample function. அதுக்கப்புறம் என்ன பண்ணணும்னா we have to apply IK and Jacobian calculations பண்ணணும். Then we have to fit function functions. So இதுல இருந்து என்ன பண்ணுவோம் அப்படின்னா we have to take a sample to get the discrete values of it. Okay. Uh, so the remaining thing I hope we can see in the next class. Okay. Uh, Thank you.